All right, let's now take a look at the reminders as usual. So, maybe it's good to look at where we are in the calendar. So we are now here, November 5th. So this week, for the scheduled lab session tomorrow, I'm going to attend both of them, and I plan to do a bit of a code demo because we're going to introduce you to the inheritance today, especially how you can use the new keywords that's to do with the inheritance. I'd like to do some demo together with you, maybe tomorrow. So I will encourage you to really attend for tomorrow, either in the morning or the afternoon. I'm sure it's going to help your lab number 4 as well. Okay, and then we don't have any scheduled tests this week, but we do have your written test number 2. The format is going to be identical to your written test number 1. I'm going to release a guide and some practice questions by the end of tomorrow, so you can also do a little bit of preparation in addition. But your safest bet will still be go over all the materials that we have been covering since written test number 1. I'll confirm about the coverage of the test tomorrow, okay, when I release the guide. All right, let's see if I missed anything. And your lab number 4 has been released last Friday. And then you definitely want to get started with it. It's kind of like a challenging lab. I would say inheritance is definitely part of it, but also it also requires a sophisticated object relationship that you have to implement for lab number 4. So you really want to spend a good amount of time struggling through. And if you got any trouble, reach out to me. All right. And for written test number 2, I'll confirm the coverage and example questions tomorrow. And also, there'll be in-lab demo tomorrow as well. I'll be there. And for your programming test 2, we already started the grading process since about late evening last Friday. But I will need to send a reminder to the TA. I will see if they can return back to me in time. I'm hoping that's the case. But still, tentatively, it will have to be Monday next week. But if we can release earlier, especially by the drop deadline, I'll try. If we cannot, then we have to wait until Monday. Okay? Anyway, I'll keep you posted. Any question about the course you want me to clarify? Yeah? Oh yeah, because the regrading request for programming test 1, because it's not due yet. It will be due actually next Monday. So I would say as soon as the submission is closed for the regrading request, I'm going to assign 1 or 2 TAs to handle them. I'm hoping to get back to you hopefully within a week to 10 days. Yeah. All right. Good. Yeah. If you want to submit a regrading request for your programming test 1, please make sure don't miss the deadline. Once miss the deadline, we're not going to handle it. All right. Any other questions? All right. Let's now do recap about what we said last time. All right, so last time we basically started the topic of aggregation and composition, right? We talked about the terminology, container versus containing, right? Make sure you understand them. And also we talk about the design diagram. Whenever you see this empty diamond over here, that means aggregation. Whenever you see some solid diamond here, that means composition, right? Aggregation means you do allow certain extent of sharing, so you may have aliasing effects. Changing one object from one address will be visible to the other variable storing the same address. That's exactly what aliasing is about. And we also talk about how you can interpret the diagram given this, right? You can review the notes for that. And these 2 are the exercises assigned to you to really do the tracing yourself. Ideally, if you want to put them onto Eclipse and really do the tracing using debugger, that'll be most ideal. But I'll leave the choice to you. And we spoke about how you can refer to the private attributes in your Java code. We started with this a little bit more contrived example here, just to say there's some principle there. Whenever you want to refer to some private attributes, whether or not it should be allowed, whether or not it should compile, depends on what's the type of the context path over here. If the context path happen to have the same class as the one you're writing this line, then it should be allowed. Otherwise, if the type of the context path happen to be Y, just another class, which doesn't really match the current class that you're making this attribute call or method call, in that way, it shouldn't compile. All right, so that's a very quick summary, but I should really go back to the example that we spoke about last time. 2 things you should do. Number 1, understand the ones we spoke about, the 2 pink ones and the 1 green one on the screen. And then you should really also try to do all the others to really make sure you understand why they compile, and some of them also doesn't compile. Any question about this? Example here. All right, I'll leave them to you. If you have trouble, you should really reach out as soon as possible so we can help you in time. And then we talk about this exercise over here, depending on which class is the context. If, let's say, if the context can be here, in that way, the way you're going to write path expression using the dot notation will be according to the context class. And also the principle that we spoke about, accessing the private attributes or even private method will be the same. And the second part will be we switch the context to another class over here. And the third example is just switch to another class over here. Right? That's also something we spent quite a bit of time last Thursday discussing it. Is there anything that's not clear to you? Apart from the fact that, of course, you got to dive into the details and try to understand yourself, right? If no question for today, that's okay. Then we can revisit that later. All right, so make sure you study that. And then we started this topic about composition. Right? We used the example of the directory and also file. And the very first one we spoke about is just to visualize whenever you're trying to create a new directory over here and you're trying to add individual files into it. Let's say there's only a single directory in our file system. In that way, you have no issue of sharing. You can see the only, for example, here, for this particular file, there's only one arrow pointing to it. So only one. There's no sharing. However, if you try to make a copy of the directory, you got to be careful. You want to make sure, for example, the shallow copy example that we spoke about, right? Shallow copy. Usually, when we say shallow copy, it simply means you're basically using copy using variable assignments over here, right? I'll make it a little bigger. The files over here is simply reference type. It's like an array of files. We're saying that rather than creating a new array and also new files, we simply reassign the address. Let's say here, this is the directory we want to copy. And then files, rather than just creating new array, which we'll see in the deep copy case, we simply let it copy the address of the existing array. So you can see now both arrays, both references, the files here and the files here, they really refer to the same array. So no new space has been allocated in the memory. We just let aliasing play in our scenario. And the consequence is, for example, if I say now I want to modify d1.files at index 0. I want to change the name of this file, for example, from F1 into F11. Now, composition will be violated because after I have changed the file name into F11, at the same time, if I try to say D2, go to files, which will refer to just the same array. That's the consequence of the shallow copy. And then I go to index 0, it's also referring to this very same file. The file name also has been changed from F1 to F11. So this composition is violated because we got sharing, we got aliasing. All right, so that's the last bit that we spoke about last Thursday. And of course, we also talk about what it means to be a copy constructor, right? Simple definition. Whenever you got a parameter type over here, just match the class you're trying to define a constructor for, then that should be a copy constructor. All right, any question so far about a recap? So we're going to continue with two more small follow-up on the shallow copy. We want to say, what should be the correct way of doing things? So rather than just letting the two references sharing the same array, we want to make sure the deep copy is implemented thoroughly. That's what we want to make sure. So if you go to the slides, you will see that slide number 26. That's how you implement deep copy, right? So if you look at the slide, we got a code over here, which I'm going to show to you how to trace it and visualize it, and then that should be good enough for the discussion. All right, let's now go to deep copy here. The idea about deep copy is you may just need copy constructor at all the levels. Whenever you want to really assign some objects, you better assign a deep copy of the objects. That's kind of the principle. But let's take a look. So we are assuming that, number one, we have a copy constructor for the file class. So this guy here is a copy constructor. I'll say copy constructor, so you know what I meant. All right? There is another copy constructor over here, and we call that, so here. This is just another copy constructor. Here's another one. In order to implement this copy constructor, it ends up, we also need to call the copy constructor over here that's defined here, it turns out. Okay, but we're going to see how exactly that's going to happen. So now in the directory class, we have two constructors that are overloaded. So one is non-copy, this is not a copy constructor, it just takes a string name. And then we got to assign the name and initialize the array. And this part over here is something that we have to trace to understand the copy constructor. All right, let's take a look very quickly before we move on to tracing it. So this might be a new syntax for you, but it's very handy. Whenever you got multiple constructors in your class, you will be able to call other constructors as if they were helper methods. Okay? So whenever you see that we're using this keyword over here, and then followed by just parentheses right away. So that means you're calling some other constructor in the same class. Okay? So I'll make a note over here for you. This is basically calling other constructor in the same class. And in this case, you can easily tell which version it is because other than name is actually a string. And there's only one other constructor that takes a string. So you know that it is that version it is calling. So what will be the consequence of calling this constructor here? So after this line here, we're going to initialize the array by size 100. That's what we assume. And then afterwards, we're going to run a for loop over here. And then depending on how long other is in the file that we want to copy. And then we got to do some individual copying here. That's something we got to trace. All right? I haven't done the tracing yet. I just want to show you the overall picture of what's going to happen. All right, let's now try to trace it together. And this will also help us for the third part, which will be some more like a question for you. Okay, let's do this one carefully. So here we got this part here. So this is something that we have done already last Thursday. We basically have created D1, which is a directory, and then we added F1, F2, F3. You can see F1, F2, F3. And NOF is currently 3. Right? That's something we have done. So let's not retrace them. Let's see something that's new. If you look at this line here, all right, this line here, we're creating D2 as a copy of D1 by using the copy constructor from the directory class. And then we're just going to see how this is going to trace into. All right, let's now trace them. Okay. Line number 1, the green one. When I trace this line here, I know that I should really call the constructor in the same class, which will be taking a string over here. And since I'm, what's other? Think about the other over here is D1. So D1 over here and the other over here called by value. Right? That's also something we spoke about, right? Think about this guy here is the other. And the other here is D1, right? And then other than name will just be basically D. And we're just going to execute this line by line over here. So this name, new string name, we're creating a new string. So that means the name here is going to be just a new string D here. And this one here is D2, right? That's what we are creating. And then the second line over here, this one here, we're creating a new array, separate array, no shallow copy anymore. So that one there is actually going to have an array over here that's going to be index 0, 1, 2, all the way to 99. And at the moment, NOF should be 0. All right? So this will be the consequence of calling this line here. All right? Just make sure you also convince yourself why it works that way. All right? And now we're just going to run this for loop over here. Let's first decide how many times we are going to actually run this for loop. Intuitively, we want to copy the file from D1, one by one. Since we got 3 files over here, you can see the NOF is 3. That means we need to run 3 iterations. For each iteration, we're going to add this file or add a copy of this file into this directory, index 0, index 1, index 2, and etc. That's what we're going to do. But let's see exactly how it's going to happen. So very critical notes for you would be if you look at other.nof. Okay? As I said earlier, other here is D1. D1.nof is 3. All right? So we know that we got I would be initially 0 all the way to 2. Right? So I would be actually 0, 1, and 2. Let me just do one of them, just the very first iteration. And for the remaining 2 iterations will be done in the identical way. For iteration number 1, when I is equal to 0. So number 1, we're going to create a new file, reference, basically. And then we say the source, which is something we want to copy, will be other, which is D1, D1.files at index 0, which is referring to this file over here. And we're just saying src, the source is pointing to this particular file. We haven't really made any copy just yet, which we'll do. And then we got the pink line here. This is critical. This one here is calling the copy constructor of the file class. So this is a copy constructor call. That is to say, given that src is pointing to this existing file, I'm going to make a copy of it and call that nf. All right? So now this call over here is actually going to, if you step into it, it's actually going to call the copy constructor in the file class. This is a critical line you want to pay attention to. Okay? And that one there, just going to create a new file objects. For example, I can put it here. So it's going to be the file, and then the name will be simply some new string. All right? And you can see this is f1.txt. So that one there will be f1.txt. And finally, if you go to the next line here, we're just going to add this new file into directory number 2 that we're constructing. Right? And then that one there, index 0, is going to point to this file. All right? So what we have achieved so far is, after iteration number 1, we have created a deep copy of the file that we have created a file over here that's a deep copy of index 0 over here, the file. You can see these 2 files have nothing to do with each other, which is composition. All right? And then we're going to continue for 0, 1, and 2 for two other iterations, right? So for second iteration, I'm not going to go back to the code. src is just going to point to the second file that we want to point to, which is here. And that one there is going to trigger just another file that's going to be created over here alone. File, and the name, f2.txt. f2.txt, and that one there for the second iteration is going to add it to over here. And one more. And the final iteration, iteration number 3, when I is equal to 2. The file over here, the name, and the source is also going to be changed to this one here at the end. And we want to make a copy of it. And then that one there is actually going to be f3.txt. And you're just going to add it to index 2. All right, so that's a deep copy. A little bit dry, but you got to know how to trace them. So summary about what we have achieved. You can see here in the new copy of D2, index 0, index 1, and also index 2, they all point to files that are deep copies from the original one. So if I modify, for example, the name of this file, does it impact the original one? No, it doesn't. Right? That's the spirit of the composition. All right, any question here? Yes? Yeah.
What do you need the word boost?
Mm-hmm. Yeah, here I just want to emphasize that whenever you're trying to implement as faithfully 100% composition, you want to make sure every object that you want to create or copy is like a new object. So rather than just saying this.name will just be other.name. Technically speaking, this might be okay because strings in Java is immutable. But I'd rather not bother going too much into what this immutability really means for this course. But instead, what we can do is, now rather than just let the name here point to here as well, why don't we just create a new string that's going to point to just a new string object here? That's the intention. Yeah. All right, any question here? All right. That's the deep copy. So when you study for this particular example here, I would suggest you definitely want to look over how we declare and define the copy constructor for directory, which illustrates to you how you can call other constructor in the same class, and also how you can call the copy constructor from another class. Right? These are the two very typical things you might want to do in your copy constructor. And then you can also look at the JUnit test cases. That one just illustrates what I said. So changing one file over here by its name, for example, doesn't impact the other one. Okay, remain the same. All right, if no further question, let me show you some exercise that we can all think about quickly. Okay, let me show you the slides. So there's some flow over there. So that's a deep copy we just spoke about. And there's a question for you. Okay. What if we have some different definition for the copy constructor? So this will be the new definition, but I'm going to show to you how we arrive that particular alternative definition. Let me show to you. Okay? So we go from here. That's a deep copy. That's a correct way of doing composition. But now what we have done was, rather than having this new file over here, we delete that line. We don't want that anymore. And then add file over here, rather than adding the file that's from the copy constructor of the file class, we simply say src. All right? That's the modification I have just made. And the question would be, are we still getting 100% composition? That's a critical question. And the way for you to think about is, if we do this alternative copy constructor for directory instead, are we allowing any aliasing at any level? That's the question. Okay? This could be tricky. I'm going to show you the answer, but before that, I just want you to know what I'm asking here, right? This could be some possible exam question, for example, right? I want you to really observe the differences between two versions of code and see what the consequence might be. That's an important exercise for you. Anyone would like to share some thoughts before I show you? Yeah, Robert.
It's not a sure key copy because you're just transferring the addresses from the other array. So they're going to be shared between both arrays.
Are we sharing array or are we sharing files? The elements inside the array. Okay, that's good. That's the essence. So if you remember in the shallow copy over there from last time, in the shallow copy, the two directories share the same array, which is not good. Okay? In the deep copy, we definitely don't share anything. But now I'm creating another possible shallow copy, just at different level. Now, let's see how it's going to look like. So let's say I'm actually calling this, right, the copy constructor. Let me set up something here. So I still have my D2, and then it has the name D. And then it has the separate array. We don't really share anything at the array level. So 0, 1, 2, 3, all the way to 99, and then it will be 0. Okay? And then, if you look at this line here, number one, we got a source. src in the first iteration is going to point to index 0. All right? And now, we don't really call the copy constructor anymore because that line there has been deleted. What we do instead is to say this, and this will be the D2 that we are creating. This one here is going to add a file, just src, which is pointing to exactly this file over here. That means index 0 over here is now going to point to this object here. And then, of course, we got to update the counter from 0 to 1. That's apparently aliasing. Specifically, if you try to check d2.files at index 0 equals d1.files index 0. If you check that one, that's going to be true. So that's not good. So that would be a violation of composition. All right. So that's really what you want to follow through from this exercise here. Yeah, question. Well, in some way, okay, the question was, this example here, where we share at the file level. The other one there is even worse, as far as composition is concerned. The other one that we spoke about last time, we are not sharing exactly at the file level, indirectly, yes. But this one here, we're sharing at the array level. So is there a difference? I would say there's a difference. Because if I say d2.files and also d1.files, we are referring to the same array. On the other hand, now if I say this one here, if I say d2.files versus d1.files, they are different objects. At least at this point here, I still don't really have any violation. It's only when I talk about the elements of the array, as Robert pointed out over here, this one here and this one here, I can see that this is the way the violation is for composition. So they both violate composition, but at different points. Yeah. Good question. All right, guys, any follow-up? All right, if no, let's now move on. Okay. Yeah, of course, it will take some time for you to really dive into details, isolate yourself, and really try to think about it so you'll be ready. All right, so this one we're done. All right, so this page here basically just summarizes about the terminology we spoke about for aggregation and composition, right? I'll let you read them through. We have covered them already. And just some easy exercise conceptually for you. Okay? For the first one, I'm going to do it together with you. But for the second one, it might be nice for you to think about it for a moment. Okay, number one. Aggregation and composition might exist at the same time. So maybe one part of your system should be implemented using aggregation. Another part maybe should be implemented using composition. Let's say your WSC lab, for example, right? So let's say there's a workstation there. So each workstation has its own CPU, monitor, and keyboard. Two machines should not share the same keyboard. It doesn't make sense. So it should be composition, right? That's easy. On the other hand, all the workstations share the same network that belongs to EECS. They don't really have their individually owned network. So that should be aggregation, right? And if you look at this diagram here, you can see that here. You can see each workstation has their own keyboard, CPU, monitor. You can see this CPU is different from this CPU. So that part there is composition. So this part here has to be sure. You have to, if you implement this part here yourself, you got to make sure there's no aliasing. This is composition. Oh, sorry. I think the box is not drawn exactly right. Let me do it again. Only up to the monitor. Okay, only this part here should be composition. On the other hand, the network over here, you can see each of the workstation is pointing to the same network, right? So this will be aggregation. All right? That's easy. Okay, let's now have a final discussion here. So let's see, this is a problem we have. Let's say we talk about published book, maybe textbook, maybe some novel, scientific, or whatever fiction you love to read. Every published book, that they have an author. Let's talk about the attribute author for each book. So every author may publish more than one books, for sure. And now the author field, or the author attributes, should we try to implement it as an aggregation or composition? Now give me some justification. Imagine that you have a classical book, and there is some concept you want to implement here in the book called author. Should we allow any sharing for author? If you don't think we should allow any sharing, that should be composition. if you believe the author attribute somehow has to be shared, then it should be aggregation. How do you think? Okay, I'll start with you. Should be aggregation? Okay, 2 books have the same author, they share the same author. For example, if the author changed their name, it should be reflected on both books. Okay, sure. Robert, are you thinking about the same?
Yeah, and also because it's just a string, right? So you don't have to worry about the
Sure. Name could be one example, or it could be other attribute for the author, right? Good. But what about this? What about physical book? Let's say a physical book here. So let's say I got 2 copies of the book. And then there's a name there about the author. If I modify the name on one book, is it going to modify the name on the other book physically? Not really, right? Because they're physically different, right? So my point is, in this example here, aggregation or composition can work depending on what the context. Okay, let me show it to you. What you guys just talked about, I think that makes total sense. Let's say these 2 are ebooks, okay? Let's say we got, so let me point to you. Let's say we got one ebook over here and another ebook over here. They have some hyperlink for you to link to the author information. There's a single copy of the author information being shared about all the books being published by the same author. If I modify the name, for example, from maybe from whatever name it is into Peter, for example, it should be reflected by all the books over here. On the other hand, if we got physical books, right? So let's say the author field has been printed out on the book. It cannot be fixed. If I use a marker to change the name on one hard copy, does it impact the other copy? Not really at the same time, right? So that's not exactly sharing. So the scenario will be different. It just depends on which one you want to choose. So aggregation and composition will have to be chosen accordingly. Now, think about these examples. They are really meant here to really help you kind of distinguish between aggregation and composition. Okay? So once you guys get to maybe 3311 for software design, you'll definitely get more design decisions to make. But for this course over here, I think understanding the diagram notation and understand the programming details will be sufficient. Okay? And so at the end, if you want to do some extra practice, I would say all the examples that we did in the slides, I didn't really make the source code available to you. So you can reproduce them in Eclipse and try them out. Okay? If you want to do extra practice. I'll leave that exercise to you. All right, any question here? All right, if no, finally, we can now start talking about inheritance. Okay? Let's now talk about it. And all the notes and slides, diagrams have been posted on the lecture site. You can check them out later. It's quite a big lecture, but I'm going to talk about them hopefully in logical chunks every time, so we can walk them through smoothly. There's no point to really rush them through if you cannot follow through the lecture. All right, so what should we learn about the inheritance lecture? We're going to see, first of all, what if you don't have inheritance? How should your Java design look like? That's something we'll talk about today. I'll give you 2 possible designs without inheritance, and maybe criticize on them a little bit. And we're going to use inheritance, and especially there will be 2 keywords we have to learn in order to program inheritance. One is called super, the other is called extends. So these are the 2 keywords. I think you have seen neither of them so far, but they are quite easy to use. We'll also see them today. And static type, dynamic types actually will come back. So we're going to revisit static type and dynamic types. And this time, we're going to make it complete discussion. And also, what I didn't really put here, also typecasting. We also got to revisit them. Okay? And ultimately, we are going to talk about 2 things that kind of go hand in hand. Polymorphism and dynamic binding. Whenever you want to revisit about what you really have learned in inheritance, always go backwards. Think about what's really polymorphism and what's really dynamic binding. That's something we'll talk about. Maybe not, possibly on Tuesday. We should be able to, there will be quite a bit of groundwork that has to be done before we can get to these 2 definitions. But we'll get there. And typecasting, which I just mentioned. All right? And the design challenge I kind of encourage you guys to do, it's still not too late, but for now, in the interest of time, why don't I just let you guys read very quickly, just in case you haven't really attempted the exercise just yet. Just take 2 minutes to familiarize yourself with the terms that we're going to use in this example here. And then we'll discuss it. Okay, 2 minutes. You can picture in your mind what classes do you need, and also what methods do you need, especially for non-resident students versus resident students. How can we distinguish between the way we calculate the tuition for them? Because for one, we got to apply the discount rate. The other one, we got to apply the premium rate. Okay. Okay, I'll let you take 1 more minute just to get yourself familiar, and then we'll start talking about it. All right, just 1 more moment, and then we should talk about the example. All right, hopefully everybody had a chance to read it. At least you know what the terms are supposed to mean. In the interest of time, let's say I'm going to summarize about 2 very typical Java implementation or design that would not use any inheritance to implement the critical classes over here. And then we're going to study them a bit and criticize on them. What's the drawback, okay? And for this passage over here, I highlighted all the key terms over here. All right, so let's go over them very quickly. So there will be a student management system class that we got to define, which will store students. So we got 2 kinds of students. We got resident students, we got non-resident students. It makes sense to create 2 different classes, or even just 1 class. Okay, we'll see. And each student should really have the name and register courses. You can see for the green attributes over here, name and register courses. These 2 are common to both resident and non-resident students. However, when you say you want to, let's say, calculate the tuition, there will be some difference you have to make between resident versus non-resident students, especially when you say you want to implement a method which will calculate the tuition. You want to make sure for resident students it's going to apply the discount rate. And for the resident students, you're going to apply the premium rates. On the other hand, for the non-resident students, you're going to apply the discount rate. So these are very important distinctions you have to handle. All right? And later on, once we learn about inheritance, you'll realize this is a very typical problem you can solve by using inheritance. But before that, let's see how the solution will look like without the inheritance. Okay? And this will be the second design I want to show you without inheritance. But for now, let me show you the first design. Okay. Okay, first design without inheritance, without. And this is how we implement it. So we have a single class called students, only a 1 student class. And we got an array of courses and number of courses, that's good. And the critical attribute here is called kind, the kind of students of this particular objects. Okay? So let's make the following assumption. So for the kind here, we might say it's integer here. So we might say when it is equal to 1, that means it is resident students. When it is equal to 0, that means non-resident students, let's say. Of course, you could have made a Boolean if you want to, but let's just make it integer for now. Because there might be multiple kinds of students. You want to make the solution more general. And in the same class, we got either premium rates or discount rate. And you can think about somehow the premium rates should be applicable to the resident students. and the discount rate should be applicable to the NRS. Right? And we have a constructor here for students. And whenever you create a new student, you have to make sure you pass the kind over here. Okay, so what do I mean? You might have something like, I can say students, let's say resident students number 1 will be new students. And for resident student, we assume it's going to be 1. I'll pass 1 over here. And I can create another student over here. And there'll be non-resident students number 1, which will be new students. And then 0. Only a single student class seems to be quite compact. I don't even bother with creating separate classes for the 2 kinds of students. Now the question is, let's say forget tuition. How do we make sure the students like over here, which is resident students, they are applied the premium rates? Similarly, the students over here with kind number 0, which is NRS, they will be applied the discount rate. How can we be sure? There's no way around. You have to have some conditionals in each method. Let's say forget tuition. I have some tuition 0 to start with, and then I'm going to go over the list of courses. Let's say we already added different courses to the student already. Okay? So we're going to go over the course one by one, and we calculate the base amount of the tuition. So you can think about this is the base amount. And then we have some conditional over here. And then we say if the kind is equal to 1, that corresponds to resident students. In that way, we apply the premium rate. If the kind is equal to 2, well, I can change, sorry, I just forgot about my convention. So I will just change that to be 0. All right? Let's be consistent with what I just said. If the kind is equal to 0, that corresponds to non-resident student. In that way, we're going to apply the discount rate. All right? So I can also change this to 1 and also 0. But this is a very typical method where, based on the value that you set when first creating the student object here, you'll do something differently. All right? Any questions so far about this solution here? All right? And there's another method here. Let's say we want to register a course for the students. Depending on what the kind is, it could be 1, it could be 0, right? You can see we got an if conditional here as well. Let's say somehow for kind number 1, we allow a little bit more courses for them to take. And for kind 0, we allow a little bit less. But the idea would be we just got different policies on different kinds of students. And then, so this is going to set the maximum differently. And then if they have already reached the maximum and they still try to register, we're going to get some error. Throwing exception, for example. Otherwise, if they haven't really reached their maximum, we're going to do the normal addition of the courses. Okay? So that's the attempt, number 1, without using inheritance. Any question about this design here? It's here, it's because we just set it to be some default value, but I'm pretty sure the kind is going to be either 1 or 0, which guarantee I'm going to reassign that to 6 or 4. Just some default value. Because I got some condition here that's going to allow me to reassign the max value to 6 or 4 accordingly. So it's okay to choose some default value. It's never going to be kept until the end. Mm-hmm. You can choose anything. For example, you might choose 0 if you want to. Yeah. All right. Go ahead. You mean the else over here? You mean here? Okay. So this is to say, we are trying to register a new course for the students. We're saying that if currently the student's number of courses has reached the maximum, in that way, we are simply just going to report some error, which may be throwing some exception. Otherwise, if they haven't really reached the maximum, then we're just going to add a course into the array of courses.
Why do you have the
is because depending on the kind of students over here, the maximum will be different. That's the policy, let's say. We're saying that if the kind is 1, resident students, let's say somehow we allow them to take up to 6 courses. On the other hand, let's say when the kind is equal to 0, let's say this student here, we assume that they are only allowed to take 4 courses a maximum, maybe because they live outside the campus for whatever reason. Yeah, one will be 4, the other one will be 6. So when you try to say, let's say this, at a runtime, if you say RS1, which was created over here, dot register some course, let's say 2030, okay? If there's another one, let's say RS2 dot register, and then 2030. So these 2 students will be treated differently. Because over here, this RS1 dot register 2030, because RS1 has a kind 1. So it's going to set the maximum to be 6, right? On the other hand, if you try RS2 dot register 2030, because RS2, oh, so NRS1, that's what I meant. Beg your pardon. This will be NRS1, which is here. And for that one, the NRS1 dot register, now NRS1 has the kind 0. Now, the kind will be 0. That means the maximum will be 4 rather than 6. So, right, you can see the register method will behave differently. Kind of follow, or you're still confused? You're good? All right. Yeah, so the essence for this design over here is we're using these critical attributes over here, kind, for distinguish between how we should implement the methods or how the method should be run for different kinds of students accordingly. Okay, that's the essence. Yeah, make sure you understand this design over here. Okay? Yeah, question? Mm-hmm. Yeah. Yes, we assume, yes. So apparently here we assume that in the course class, we have some attribute called fee. We can assume that, let's say. Yes. So that's why we can calculate the base amount over here. The base amount calculation will be the same for either kind number 1 or kind number 0. However, kind number 1 should be applied premium rate. Kind number 0 should be applied discount rate.
Fee is a private attribute. How can we access it?
Yes, that's a very good observation. Yes, for now, I'm just making it very simple. Let's say we should not do that. Let's say fee is public. How about that? Or I can simply say get fee. That can also work. All right. All right, let's now criticize on this design. This design here makes sense and may be very close to what you can do the best without inheritance, but it has very bad drawbacks. Okay. Number 1 is something called cohesion. I'm not sure if you heard about this term, but it's a nice term to really learn about. It's a design principle, cohesion. Cohesion has the following definition. I'll write it down here. Attributes and methods in the same class should be under a unifying theme. Or put it another way, you shouldn't put unrelated attributes or unrelated methods in the same class. That's cohesion. What we want to see now is how can this particular design violate the cohesion principle? Somehow we put stuff that are not really related to each other in the same class, somehow. Okay, anybody see that? It's this class that violates that principle. Which attributes or methods you think they don't really belong to each other? They should be separate. Premium rate, discount rate. these two attributes should not be put in the same class. Premium rate only belongs to resident students. Discount rate only belongs to non-resident students. They should not in the same class. They should not be. Okay, it's a violation. Violation of cohesion. So the ideal solution will be separate them into two different classes, which I'll show to you in the second design attempt. All right, so this is one thing. Another one is, in some way we can also say, when we talk about helper method, we say the code can smell. The code also smells over here. But to be more general, there is something called a single choice principle. You can also see on the slides. I also got some definition there. Let me show you exactly how that violates it. So now, depending on how many methods you might get, but having just these two methods already tells us how the single choice principle can be violated. It's really about repeated if conditions, depending on what kind of students we have. So I'll show to you. So you can see here, we say if the kind is equal to 1 versus the kind is equal to 0. Here, we are repeating in another method, if kind is equal to 1, and also kind is equal to 0. Because the way we design this class over here, every time when you create a new student, you must specify the kind over here. So that means accordingly, for any method you want to execute, if there's any distinction between the behavior of kind number 1 and kind number 0, you have to repeat this check of the if statement. No way around. All right? So you got to do this one for get tuition. You also got to repeat this if condition here as well. You got to do for every method in your class, basically, because you rely on their attributes kind to tell you what kind of student you're talking about. And the method should behave accordingly. So number one, we identify the repetition of the if statement. And let's see how the so-called single choice principle is violated. Single choice principle tells you the following. Whenever there is a change to your classes, you should change only a single place in your classes, or the minimum number of places. Now, let's say, assuming that, let's say we want to have a new kind of student, let's say international students. So, for example, let's say we want to have international students. Let's say the kind correspondingly is going to be, let's say, 2. So far, we already got kind 0 and kind 1. Let's say we want to increment by saying 2. So that's why having integer is a better choice than Boolean. Boolean wouldn't allow you to have more than 2 choices. Now, you want to imagine to yourself, if I got another new kind, which is 2 here, how many places do I need to modify? Wow, 2 places, right? Whenever we want to distinguish between the kind of students, we need to add a new branch, basically. So we're going to say, number 1, we're going to add a new branch to say, else if this kind equals 2. And then we might do something over here. That's one place. Another place, we go to maybe this one here, and then we say, else if this kind equals 3, and then we do something over here. You can see we are basically implementing this new change over here about international students, place number 1 and place number 2. So multiple places. The single choice principle tells you that you have some repetition here in your code. So if you want to introduce a change that's to do with the repetition, you got to modify them multiple times. That's not a good practice. To really obey this principle, you have to make sure there's only a single place you change. All right, any question here? I would say this design that I presented first maybe is the trickier one to understand. The second one is actually easier, but this one is also worth understanding. Okay? All right, so what should you learn from this example here? Number 1, you want to make sure you understand the design over here. Okay, understand how it works, and then understand the design principle for cohesion and the design principle for single choice principle. And then you want to understand how the first design attempt violates the cohesion and also how it violates the single choice principle. These are the stuff like a checklist for the points you want to review when you study this. All right, anything you want me to clarify before I move on to the second example? So the first example, the first design we had, pretty bad. It violates cohesion. It also violates single choice principle. Let's now try to make some improvement. I'm going to give you a design still without the inheritance. But that one there is going to have good cohesion, but not good single choice principle. All right. Okay, just before that, why don't we take a very short break and then take in attendance, and then we'll resume. All right, so before the break, we spoke about the very first design without inheritance. So please do spend some time studying through it. And then if I can make some remark, maybe a little bit later, once we finish the inheritance lecture series, I can go back there and tell you that the following. If you're in a language without any inheritance support, for example, you're programming in C, but you want to simulate how inheritance work, what I just presented in design number 1 is how you would do it. It sounds a bit advanced, but you can copy that remark, maybe think about it as we're going through the inheritance. But we should feel lucky, we do have all the inheritance keywords, mechanisms supported in Java, so we don't really need to go there. But if you're programming some non-OO language like C, that's what you got to do to simulate. But that's more advanced subjects, okay? But just want to let you know. All right, design number 2, which I can just use a slide to show to you, okay? Let's now consider, again, don't forget, you want to have 2 design principles in your mind, cohesion and single choice principle. As I present through the second design, think about, is cohesion really there, or is single choice principle really there, right? All right, design number 2. We want to have one resident student class. Resident student class here, and we got name, and we got courses, we got number of courses, straightforward. And also we got premium rates, which is applicable only to resident students. And also we got a constructor for the resident student, which does very sensible things. And also we got register. Let's say we're not worried about the maximum for now, okay? It's a different design. We got register here, which will just unconditionally register the course, okay? And also we want to calculate get tuition. And the get tuition here is going to calculate, number 1, the base amount. That will be the same as the design number 1. But afterwards, because we know we are under the resident student class, we don't need to distinguish between kind 1 and kind number 0. So we can apply directly premium rate. Okay, that's the first class. And now the second class is going to be the non-resident student class. So we got 2 classes here rather than just 1. So non-resident students here, again, each non-resident student has their name, courses, and number of courses. And also we got discount rate, which is only applicable to non-resident students. That's why we put it there. And we got non-resident student constructor here. And we got register. And let's say for now, register, there is no need to distinguish between non-resident and resident. The same, just unconditional. And also we got get tuition here. And the same code is going to calculate the base amount. But just at the end, since we know that we are now in the non-resident students class, so we're going to apply the discount rate. That'll be it. All right. So now I would like to ask if any one of you can already think deeply. Given that we got resident versus non-resident students, premium rate is only here. Discount rate is only here. And we got constructor here, and also we got other things. For example, get tuition here. One of them is going to apply premium rate. The other one is going to apply discount rate. Now, can anybody tell me, is cohesion satisfied here? If you think yes, why would you think yes? Quick answer. That should be not so difficult. Yeah. Question. How about let me have that answer first. and that'll answer your question. Just hold it. Just remember that. Yeah, go ahead. Yeah, exactly, right? So cohesion tells you can go back to my definition before the break. In a single class, all the attributes and methods should be related to each other. So now in the resident students, we don't have discount rate anymore. And in the non-resident student class, we don't have premium rate anymore. So they're separate. So that's exactly the answer. Cohesion is good. How about single choice principle? Single choice principle usually will be hinted by if you got any smell in your code or repetitions. Do we have repetition here though? If you notice my color hints, the only differences between these two classes are highlighted in yellow. Everything else are repetitions. For example, you can see here, we got name, courses, NOC, name, courses, NOC. So these three are repetitions. And also the constructor implementation here, also repetition. And also the register here, let's say we don't have any distinction between the maximum, let's say, also complete repetition. And also get tuition, not exactly fully repeated, but you can see that most of it, especially the code for calculating the base amount, is also repetition. The only difference is the premium rate and discount rate. So this class over here violates the single choice principle very badly because it got repetition. Okay, I'm just gonna hand wave a little bit. That's something I would like to show to you how you can see that in Eclipse tomorrow. Okay, so for now, for example, if I want to modify the get tuition, let's say, so now let's say rather than premium rate, discount rate, let me say I want to apply another inflation rate, let's say. How many places do I need to modify? 2. I need to modify here and modify here. I might need to say multiply and multiply inflation rate. Inflation rate. So there are multiple places I need to modify, not just single one. Okay, that's something I said in the slides, but I want to hand wave a little bit, but I want to show this to you more detail tomorrow in the in-lab demo. Okay, but we can save the time in the lecture for something else. And some very simple exercise for you. So this piece of code before Thursday, I would suggest try to, you don't need to really trace it on the paper or Eclipse. I would say just look at them, each one of them individually to see how exactly they should really work at a runtime. So for example, for resident students, you can assume that you got one method there where you can set a premium rates for the students, maybe something. You can set a discount rate for another student to be something and calculate the tuition accordingly. So this piece of code, try to understand how it works before Thursday. All right, it's not difficult, right? Because we haven't even talked about inheritance yet. All right. And we got about 13 minutes or so. Well, now it will be now the time to introduce to you how inheritance can be programmed. Let's now take a look. And then I'll make some annotation as well, but let's now go over the structure first. Okay, so slide number 7 will be your exercise. Try to look at the code and really make sure you understand how exactly things should work. And then, so this is something I will show to you in tomorrow's in-lab demo. Okay, and let's now take a look at, so this one I'll revisit. This one also for next time. I want to go directly to inheritance. Bear with me. Okay. Sorry, that's something we'll talk about on Thursday. Don't worry, I'm not skipping. Okay, just next Thursday. Okay, there we go. This will be the inheritance solution. What we're going to do is we're still going to have resident students class, and also we want to have the non-resident student class. We still got 2 classes. But now, in order for us to obey the single choice principle, we want to introduce another class, which is so-called a superclass of these 2. That's inheritance. And you can think about, for now, the way to think about a superclass, of course, we use arrow here. We're going to learn about keywords extends and extends. So we say that resident students extends the students. And also non-resident students extends the students. Whenever you got inheritance, the first thing you want to think about is code reuse. whatever you define in the parent class, in this case, students, can be reused or inherited in all these child classes. Okay? That's something I want to show to you. Then let's now go over some slides, and then I'll do some annotation. So we have a class called students. And everything that's shared or everything that's in common between resident and non-resident student, we're going to put it in the students for sharing purpose. And don't get confused. When I say sharing, I don't mean aliasing. I really mean sharing the code. Okay? So we got name here, we got courses here, we got NOC here. So these things will be common to resident, non-resident students. Also here, we got a constructor here for students, and these two lines of implementation will also be shared or inherited later. We got register, which will be shared or inherited fully. We also got get tuition, but the get tuition here is interesting. That one there only calculates the base amount. It hasn't calculated by considering like a premium rate or discount rate just yet. But this code here will be reused as well. Okay? Let's now take a look at the second class. So we have resident students class, but now, different from design number 2, we're going to say extends students. So this is the first keyword you have to know for inheritance, extends, which might be useful for your lab number 4. Okay? So I'm saying that resident students extend students so that everything that's declared or defined in students will be available for use in resident students. Okay? Let's now make some annotation here. So I already talked about the student class. Okay? So let's now talk about resident students class. And we got the extends keyword. So the extends over here really means code reuse. Reuse. Everything declare in the students. And the student is so-called the superclass. Students, and student here, is inherited to the resident students. Okay, I'll just say RS. Resident students and resident students over here. That's how you understand the extend keyword. Pretty handy. And something very similar, we also got another class over here called non-resident students. Over here, also extend students. So that's why you see one arrow pointing to here and one arrow pointing to here. Okay? And some terminology. The students in this case is so-called the parent class or the superclass. On the other hand, let's say the non-resident students, which extend students, you can say it's a child class or it's a subclass. You can stick to either parents versus child or super versus sub. All right, either way. All right, and then if you look at the contents for resident students, so the premium rates over here is some newly declared attributes. If you think about this one here, the premium rates, and also the discount rates over here. Okay, let me say this is star, this is the star. So the star here is something very typical. So these are the new attributes declared in individual classes, individual child classes. Okay, that's one thing you can do. Whenever you're creating a subclass, you can definitely define something new. That makes sense. We inherit features from our parents, but we can also have some unique features of our own, right? It's a real life analogy. And then, if you look at the constructor, resident students, which correspond to the class. Non-resident students also correspond to the class. All right? So there is the second keyword you have to learn, super. All right? And there are two uses of the super here. Let me just show you how the super is being used, and then we'll talk about it. And also for get tuition over here, one thing to connect. Do you remember the equals method? Right? We said the equals method was already defined in the object class. And the way we are redefining that is called overriding in individual, like a point v2 class. We're doing something very similar. The get tuition method over here is already defined in the parent class. And now we are trying to redefine that. So we are overriding it, just like how we override the equals method earlier. All right? So I'm going to draw this get tuition here. And also the get tuition over here. You can think about like here. The get tuition is overridden in resident students. Similarly, you can see the get tuition here is also being overridden in a different way. Okay, that'll be good. That's also overridden in the non-resident students. So the same parent method somehow is overridden over here using the premium rates. It's also overridden here in a different subclass using the discount rate. Okay? And then let's now talk about the use of super. This is critical. Without a super keyword, the overriding wouldn't work. Okay? So there are two instances. Let's look at this class first. We got super here, and we got super over here. Okay, two supers. These are the typical usages. Let's now talk about the first one. Star, star. Whenever you say super and then you got parentheses right away, that means you're calling the constructor from the superclass. Okay. If you say super over here and then you put something over here, that means you're trying to invoke the constructor from the superclass. And in this case, we're saying the following, like calling a helper method. So super over here, we call the name. That means we are, let me just make it better. So super here is referring to the constructor in the superclass, which is students. And we're passing the name of the resident students. That one there is going to set up the name and also the register courses. So we don't need to repeat the code. It's already there. We're reusing it. What about the second usage of super? So this one here, it would be, let's say, star, star, star. Okay? So we are talking about this super over here. Whenever you have something like a super dot, that means you're calling the parent or superclass version of the method. Okay? So now star, star, star. So when you say super dot some method, and then passing something here. So that means invoke the version of method in the superclass. All right, let's now think about what's going to happen here. When you invoke the constructor over here, it would be as if you wrote these two lines in here. But you didn't have to write them because you can just reuse them from the parent class. Also, when you say the super over here, get tuition, it would be as if you actually wrote these lines of code, but you don't need to do it now because they are already there in the parent class. When you say super.getTuition, it's going to call this block of code, return back to you the base amount. And then in this child class, resident students, you're just going to apply the base amount with the premium rate. Similarly, let's say the non-resident students class. When I say super.getTuition, it would be as if I wrote these lines. I didn't have to write them. And then calling this block of code is going to give me the base amount. And then once I got the base amount, I can apply discount rate versus premium rate. All right? All right, any question here? Yeah, go ahead.
Yeah, so apart from the tuition itself, let's say we had any other variables
Yep.
and we had to, generate our getters and setters. Would we put them in the subclass or in the superclass?
Okay, interesting question here. So the question was, what about we want to generate some getters and setters? So here you can see depends. If you want to generate getters for name, for example, because the name is declared in the student class, the parent class, so you generate get name over here because it belongs to the parents. But the get name will be shared into both classes at the same time. On the other hand, what about get premium rate? Premium rate was not declared in the parent class. On the other hand, it was declared over here. So you generate the get premium rates in this class instead.
So if we call it get name, for example, we don't have to define it in the subclass. It'll just automatically call
Exactly.
it.
So let me make a final remark, and then we'll continue on Thursday. Bear with me. If you generate, let's say, an accessor get name over here, that one there is going to be inherited automatically to here. You don't need to define them in the child class. So guys, this is what you should do. Before Thursday, go over this page very carefully, try to understand what's going on. I'm going to recap from here. Everything we're going to talk about inheritance is going to be based on code reuse over here. All right, I'll see you tomorrow in the lab.